Okay, so today we are completing the remaining part of the ADP past paper 2021 May June paper 42. We were done with the first two questions in the previous one, and this is question number 3. And as you can see that it looks like from the chapter of light that includes lenses as well. Let's start off with this one. A student measures the focal length f of a convex lens. She sets up the apparatus as shown in figure 3.1, and then we can see the apparatus as well. The illuminated object is in the shape of an equilateral triangle as shown in figure 3.2. The object is drawn full scale. When they say the object is drawn to full scale, that means whatever you measure on the paper represents the actual length or the actual dimensions of the object. So if on the paper the length is 2 centimeter, that means in reality the length is also 2 centimeter. Or if the height is 5 centimeter, the actual height would also be 5 centimeter. She switches on the lamp and places the lens at distance u 20 centimeter from the illuminated object. She adjusts the position of the screen by moving slowly backward and forward until a sharp image of the illuminated object is formed on the screen. The image of the illuminated object formed on the screen is shown full size in figure 3.3, and we can see the image of the illuminated object as well. Alright, the question is state two differences between object and the image. If we are able to get both of them right, only then we'll be awarded to 1 mark. So one of the differences, if we compare this object with this image, right? One of the difference that is obvious is the size of the image is greater than the size of the object. Or we can also say that the image is magnified. Image is larger than object. One of the differences, if we compare the object with the image, we can conclude that the image is upside down with respect to the object. So we can say the image is inverted. Image is inverted. On to the part 2. Measure the height h0 of the object and measure the height hi of the image. So now you'll be needing to do it with the help of a ruler, and the answer might be different. I mean, once again, once you print it on the sheet of paper, the dimensions might be changed a little bit, so the answer might be different to the one that is provided by the Cambridge. So we quickly have a go at measuring the distance h0 with the help of a ruler and hi with the help of a ruler in centimeters. And what do we get from there? Followed by any other digit? Alright, so on our sheet of paper, it is 0.8 centimeter. Once again, this answer might be different from the answer provided by the Cambridge because for different prints, the dimensions are a little bit changed. May the height hi of the image, and that one is alright, so we have this one 2.3. In the part B, calculate the magnification m of the image using the equation. For ADP, Whenever they ask us to calculate something, generally the formula is also there. So we don't need to memorize these formulas, especially for this one. But for other two papers, we do have to. So 2.3 divided by 0.8, answer would be greater than 2.3. All right, 2.9. And with magnification, we don't write a unit because the unit of HI was centimeters and the unit of H naught was also centimeters, and these two units were cancelled out. That's why magnification has no unit. Alright, over to the next one. Calculate the focal length f of the lens using the equation f equals to mu over 1 plus m. So we simply need to plug the values in the formula. Instead of magnification, I'm going to write 2.9. Instead of u, I'm going to write 20.0. Once again, in the data 20 centimeter and 20.0 centimeters, they represent different things. I mean, it tells you about the instrument that is used to measure these values. And once we have written 20.0 centimeter, that implies that your instrument was able to measure to like 10th part of a centimeter as well, or in millimeters as well. But the actual reading was 20, exactly 20, so we didn't write anything. So 1 plus m, m is once again 2.9. And whenever you have a situation like this, you always hit the fraction button first on your calculator and insert whole of the data as it is. And what do we get here? 14.87. So I can write it as 14.9 centimeters to one decimal place only. Alright, so this one was pretty simple one, 4 marks, and pretty much straightforward marks. You didn't have to apply any concept of physics, just some mathematical formulas and sorting out the data, handling the data and stuff like that. So let's move on to the next one. That is question number 4. It reads, a student uses a plotting compass to plot the pattern of magnetic field around a straight wire that is carrying current. The student sets up a circuit as shown in figure 4.1. So what do we have is basically he has connected a battery with a resistor which is there to just control the amount of current passing through the circuit. And then we have the switch and the connecting wires, and then around the connecting wire, or we're passing the connecting wire through a horizontal rectangular card, making a hole through that. Anyway, the wire is arranged vertically and it passes through the middle of the horizontal rectangular card. Describe how the student uses the plotting compass to plot the pattern of magnetic field when the switch is closed. You may add to figure 4.1 to explain to help you explain your working if you wish. Alright, so this one is very popular one, and this is kind of an experiment that we study from our middle school science as well. So we'll like go about this one as well. We had a similar question in the other variant as well in 4.1, and I've seen like this question plenty of times. And these are easy marks, to be very honest. You get this question not only in paper 4, but you get the very same question in paper 2 as well. So it's a very important question and very simple method, a method that we study in middle school science as well. So let's see how we go about this one. So what we have to do is we need to find the pattern of magnetic field that is produced when the current is passing through the wire. And this is one of the effects that we'll be studying in electricity as well, that whenever current passes through the conductor, electricity is produced. Oh, sorry, when current passes through a conductor, electricity is obviously there, but magnetic field is produced. So we need to find the direction of the magnetic field. So what you can do is you place the plotting compass, the very same one that they have shown. So I'm just going to copy paste this one, the very same compass. So like here we have this one, and I can, so you bring the compass and you place it on the rectangular card. Bring the compass and place it on the rectangular card. The needle of the compass will point somewhere in a certain direction. And for this one, let us say, all right, I'll be just drawing it by myself. So I have placed the compass, plotting compass over here, and the needle of the compass points in a certain direction. Let's say over here. So what we do is the point where the needle of the compass points, we draw a dot there with lead pencil, okay? Then what we do is we place the compass, the very same compass, on the dot and find the new position of the needle. And we find where the needle is pointing at. So let's say the needle is pointing over here. What do we do then is we place another dot over there. After that, we place the needle, we place the compass on the next point, and we try to find the direction of the needle, or we try to find where the needle is pointing at. We draw another dot there. We repeat the process several times at different places. I mean, you complete this circle first, then you can place the compass, let's say somewhere over here, then repeat it. You'll get a magnetic field pattern in a circular form, or whatever the pattern is. They haven't asked for the pattern, they just have asked for the method. Now we summarize it. So we can be writing the student places the compass on the cardboard. He then mark a Alright, so this is how we can answer for this one part, and you can add this thing on figure 4.1 as well. That helps explaining the answer. So this is a standard method. um, you get this one plenty of times. Sometimes you get a question in which you have to uh, in which they ask how to find direction of magnetic field for a bar magnet. So we use the same method. The only difference is we place the compass, plotting compass, at one corner of the bar magnet. So let's say if this is your bar magnet, North Pole here, South Pole here. Right, so let's say this is North Pole, this is South Pole. So we just place the compass someplace over here. The compass would be pointing somewhere. We place a dot, place the compass on the dot again, find the new direction, mark a dot over here, place the compass on the dot, find the new direction, and keep repeating that. Then we place the compass over here. So similarly we complete for 2 to 3 rounds. Alright, the second part is state what else the student can deduce about the magnetic field in this investigation. Alright, we will learn one thing, that the pattern of magnetic field gives us very important information. First of all, the needle points, if we have the um, plotting compass, then the needle can also give us the direction of magnetic field. So we can write here, he can also know the direction of magnetic field as well. Not only the pattern of magnetic field, the pattern might be circular, might be straight lines, it can be a different one. In this case, we'll study that in current electricity. When we have a straight wire, then the pattern of magnetic field is circular. So not only he knows, or he can know about the pattern of magnetic field, he can know about the direction of magnetic field as well. So no need to answer for what would be the direction of magnetic field in this case, because that is not the point of the question. The question was just to tell what else can be found in this investigation. And another thing is we can also find the strength of magnetic field, and we'll learn one thing, that if the place where the magnetic field lines are close to each other, the magnetic field strength is strong there, and the place where magnetic field lines are apart from each other, the magnetic field strength is weak. So this is an extra thing that we'll be studying in the section of electricity and magnetism. So that is the end of the paper.